Hello everyone, welcome to my channel. In this video, we are going to start with the chapter 1 of class 10 standard maths, that is real numbers. So basically, we will be doing introduction in this video. So let's start. In class 9th, you must have learned about real numbers, right? So we will be learning that concept again in this chapter, but with more concepts, more new concepts. Okay, so we will begin with two very important properties of positive integers, namely the Euclid's division algorithm and fundamental theorem of arithmetic. Okay, so we will use the Euclid's division algorithm to compute the highest common factor of two positive integers. Now you must have learned about finding the highest common factor of two integers in your earlier classes, right? Like if you are given two small numbers, say 24 and 16, you used to find factors of this. Yes, you used to find factors of these two numbers and you would compare and find out the highest common factor, right? So in this case it is this, right? This is the highest common factor, that is 8 is the highest common factor of these two positive integers. But what if I give you two big numbers, say 485, 689? So if I use this method here, it will take a lot of time, right, to find the highest common factor of these two. So Euclid's division algorithm will help me to find the highest common factor of these two big numbers quickly. If I use this, it will be very time consuming, right? So this is a very nice advantage of this Euclid's division algorithm. Okay, what is the next concept? The next concept is fundamental theorem of arithmetic. What does this say is, okay, let me write this first. Fundamental theorem of So what does this say is, every composite number can be expressed as a product of primes in a unique way. So you can see in this sentence, composite number and prime numbers comes. So first of all, you should know the definition of composite number and a prime number. So what is a prime number? So a number is called a prime number if the divisors of that number are the number itself and 1. If these two are the only divisors, that means it is a prime number. Like suppose 11 has only two divisors, the number itself, that is 11, and 1. But 12 is not a prime number because it has divisors other than 12 and 1. So which are the other two divisors? It is 2, 3 and 4, and 6 also is there, right? Yes. So if a number has divisors other than the number itself and 1, that means that is a composite number, right? So that means 12 is a composite number and 11 is a prime number. You can see many examples in this. Like 7 has only two divisors, 1 and 7, so it is a prime number. What about 6? 6 is not a prime number, it's a composite number because it has divisors other than 1 and 6, that is 2, 3, right? Yes. So that is the concept of prime numbers and composite numbers. Okay, so let us come back to the statement of this theorem, fundamental theorem of arithmetic. every composite number can be expressed as a product of primes in a unique way. That means, so let us take an example. Say 15. Now 15 you can write in terms of primes, that is 3 into 5, right? So you can also write it in terms of this way. You can change the order also. So you can express 15 in only this way, that this is the unique way. This is the one and only one way to represent 15 in terms of primes. You can't represent this in any other way. So this is the meaning. So this is the meaning of the fundamental theorem of arithmetic. Okay, you can check for other examples also, right? 12 you can write in terms of 2 into 2 into 3, right? In terms of primes you can write 12 in this manner only, 2 into 2 into 3, right? You can also change the order. That doesn't matter in this statement. What is important is this is the only representation of 12 in terms of primes. You cannot write it in terms of any other number. Okay, so that is the meaning of the statement. Okay, so now we will be looking at two main applications of fundamental theorem of arithmetic. Okay, I'll just explain this you in brief. So the first application of fundamental theorem of arithmetic is, so first application is to prove the irrationality of many of the numbers you studied in class 9th, such as root 2, root 3 and root 5, right? So this you must have learned in your lower classes, right? And these are irrational numbers, and we will be proving these numbers irrational by using this theorem, that is fundamental theorem of arithmetic. That is one application. What is the second application is, you must have learned about rational numbers also, right? In your lower classes, rational numbers are of the form p upon q, right? Where p and q are integers and q cannot be 0, right? So if you are given a rational number, say if you are given this number, now what is the decimal expansion of this number? It is 0.666, right? So this decimal expansion is non-terminating and repeating, meaning it doesn't stop and it keeps repeating, it goes on, right? So to prove, to check whether a rational number, to check whether a decimal expansion of a rational number is terminating or non-terminating repeating, we will be using this chapter. We will be using this theorem, fundamental theorem of arithmetic. Okay. So we will be learning these two concepts in more detail in the coming videos. This was just the introduction. Okay. Thank you.